Hello, welcome to today's math class. Today we're going to study inverse proportional functions. First of all, let's look at an interesting example. When acrobats perform a nail board show, the audience will be worried when they see a lot of nails. But some say the more nails, the safer the actor. The fewer nails, the more dangerous. Do you agree with that? Why is that? The problem is actually related to the inverse proportional function that we're going to talk about. Next, we will explore the concept of inverse proportional functions and learn how to determine whether a given function is inverse proportional. What is the inverse function? The inverse proportional function is a special type of function that can be expressed in the form y(k) divided by x, where k is a non-zero constant. This means that as the value of x increases, the value of y decreases accordingly, and vice versa. Now let's look at a few examples and see what they have in common. Let's take a closer look at the inverse proportional function with a practical example. For example, the Beijing-Shanghai Line Railway is 1463 kilometers. If the average speed v of a train changes with the change of the whole running time t, then we can write the function relationship v 1463 divided by t of the speed v with respect to time t. This is a typical example of an inverse proportional function. When we need to find out the specific expression of the inverse proportional function, we can use the undetermined coefficient method. This consists of 4 steps. First, formulate the general form of the function, then substitute the given conditions to get the equation for k, then solve the equation to find the value of k. Finally, the k value is substituted back to the original equation to determine the final functional analytic expression. Let's take a concrete example to illustrate this process. Human visual function is greatly affected by the speed of movement, such as the driver's field of vision will narrow with the increase of speed. Suppose that when the speed is 50 km/h, the field of view is 80 degrees, and the field of view f is the inverse proportional function of the speed v. How do we find a function of f with respect to v, and calculate the visual field when the speed is 100 km/h? Using the method we just described, we get the answer to be 40 degrees. Today, we learned the concept of inverse function, knew how to judge whether a function is inverse function, and learned to use the method of undetermined coefficients to solve the inverse function. I hope you can remember these important points and complete the relevant exercises after class to deepen your understanding. If you have any questions or need further help, please feel free to contact the teacher. Thanks for joining us today. See you next time.